So Charles' law states the direct relationship between temperature and volume. So I have two balloons that are of slightly different sizes. You can tell this one's bigger than this one. I have some water I've been boiling and a glass measuring cup. And I'm going to put the boiling water into the cup, and then I'm going to put the balloon inside. As the hot water transfers energy as heat to the balloon, the air in the balloon will heat up and it'll move faster, and the particles will move further apart, so the balloon should expand and get bigger, which shows that as temperature increases inside the balloon, so does the volume that the particles take up. So I have hot water. I put the balloon inside. I'm going to take it out quickly. Now you can see that the balloons are almost the same size, which shows that this balloon got a lot bigger and the volume expanded in the hot water. So next, for Charles' law, I have a balloon again, which I'm going to put in my freezer for a few hours. The original size of the balloon, when measured from the end to the top point, is right about 24.5 centimeters. And I'm gonna put it in the freezer for a couple of hours. The warmer balloon will transfer its energy to the cooler freezer, which will slow the particles inside down. As the temperature decreases, the volume inside the balloon will decrease. So the balloon should be shrunk when I take it out of the freezer in a couple hours. Okay, so I'm gonna start out with Gay-Lussac's law, which states the direct relationship between pressure and temperature. So as one increases or decreases, the other will do the same. So I have a plate, water with food dye on it, a candle, a lighter, and a glass to put over it. So I'm just gonna light the candle and put the glass over it. So as the glass goes over the candle, the air around it is going to get heated up and expand, which increases the pressure inside. In the process of combustion, so as the candle burns, we'll use up most of the air and turn it into carbon dioxide and water vapor. So as the oxygen runs out, there'll soon be not enough for the flame to continue, so it'll go out. And as the candle burns out, the air around it will cool and the pressure will decrease, and the pressure outside of the glass is greater than the pressure inside of the glass, and to create an equilibrium, it'll push the water to fill up the glass. As you can see, the water is a lot higher. So next, I have a can with a little bit of water in it, and then I have a tray with cold water. So when I heat this can and I increase the temperature, the pressure will also increase, because as the water is moving around faster and faster because the temperature increases, it's going to exert more pressure on the inside of the can. When I quickly dump over the can into the cold water, the water vapor that's all around in the top of the can will quickly condense into a few smaller droplets. And the smaller droplets exert much less pressure inside the can than the water vapor would. At this point, the can has much less pressure than the outside pressure, and the imbalance causes the can to collapse. So the increase in the pressure in the can when it's heated, and then the sudden decrease when it rapidly is cooled down, demonstrates Gay-Lussac's law. So this is heated up, but it says not to dump it until there's water vapor coming out of the top. So I'm gonna let it keep heating up. Okay, so it didn't work with the Arizona can, so I'm gonna try again with a smaller can and see if that has anything to do with why it wasn't working. So there's water vapor coming out of the top, so I'm going to tip it over now. Holy smokes. Boyle's law states that volume and pressure are inversely related. So as pressure increases, the volume should decrease and vice versa. So first I have a bottle, which I crudely cut a hole in, and I have a balloon. I'm just gonna stick the balloon inside the bottle and secure the edges around, around the top of the bottle. So it's just like that. And then I'm gonna inhale some of the air through this hole. By inhaling some of the air inside the bottle, the pressure inside the bottle will decrease, and the volume of the air inside will increase as the air molecules become more spread out. Because of the increase in the volume of the air molecules inside the bottle, the balloon will blow up. And as I release, the bottle will fill with more air, which increases the air pressure inside the bottle. And as pressure increases, volume will decrease, and which is why the balloon deflates. So it doesn't blow up a whole lot, but you can definitely see the difference when I inhale some of the air, and then it deflates again. So it just blows up a little bit, but it does blow up, and then it deflates again. The cold water.